Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at terminating and recurring decimals. So by now you probably know that we can write fractions as decimals. You probably know half and 0.5 are the exact same number. So we can do this with any fraction. We can write a third as a decimal. Turns out, if you write a third as a decimal, it's 0.3333333333. The threes go on forever. That's what these three dots mean. It goes on forever in that pattern. So here we have two different types of decimals, terminating and recurring. So terminating means that the numbers after the decimal point eventually end. This one has only one digit after the decimal point and it ends. It stops. So that's called a terminating decimal. Whereas for a third, the numbers after the decimal point kept going forever and ever and ever. So that's what we call recurring. Recurring just means it keeps going in a pattern. So some decimals are terminating, some are recurring. So when the decimal is recurring, we need to know how to write it in exact form. Of course, we can't just keep writing threes forever. That's boring and impossible. So what we do instead is to write it in exact form, we write the decimals and put a dot or a dash over the numbers that keep going. It doesn't matter whether you write it with a dot or a dash, they mean the same thing. So this means 0.3, but the dot means the threes keep going forever. 0.333333, they go on forever. So if you have a recurring decimal like this, I know it's a recurring decimal because the three dots mean it goes forever. Here we have 23, just keeps recurring, 0.23232323. To write that in exact form, I just put a dot or a dash over the numbers that are recurring. So I only put the dot or dash over the numbers that are recurring. If there is a number that is not recurring, I don't put a dot or dash over it. So for 0.7111111, this is recurring. We know because of the dots here, it goes on forever. But here only the 1 is recurring, not the 7. The 7 doesn't keep going forever and ever. So this is still a recurring decimal. In exact form, we write it like this. We only put the dot or dash over the 1 because only the 1 is recurring, the 7 is not. All right, let's now look at converting fractions to decimals. So to convert fractions to decimals, we're going to use the short division algorithm. You're going to do it the same way, whether it's terminating or recurring. It's just that if it's recurring, you'll see a pattern, and you stop when you see the pattern. So let's look at 1 over 8, which turns out to be a terminating decimal. 1 over 8 is the same as 1 divided by 8. Another way to say that is how many times does 8 go into 1? So what you do is you write the numerator, the number at the top, with some decimals. So of course 1 is the same as 1.000. It doesn't matter if you write the wrong number of zeros here. That doesn't matter at all. So let's use the short division algorithm. So what we're doing is saying how many times does 8 go into 1? Well, 8 goes into 1 no times. It doesn't really go into 1, and there is 1 remainder. So we put the 1 there. Now, when you're doing this short division algorithm, it's really important that decimal point always above decimal point. So now we say how many times does 8 go into 10? Well, 8 goes into 10 once, remainder 2. 1 times 8 is 8, and there are 2 left over, so we carry them over here. Now we say how many times does 8 go into 20? Well, 8 goes into 20 twice. 2 times 8 is 16, and there is 4 remainder. So now I say, how many times does 8 go into 40? Well, 8 goes into 40 5 times. Now, there is no remainder. 8 times 5 is exactly 40. So because there's no remainder here, we've stopped. We can't go any further. 1 over 8 is a terminating decimal. So 1 over 8 is equal to 0.125. They are the exact same number. All right, let's look at 5 over 12, which is a recurring decimal. So we're saying how many times does 12 go into 5? So again, I'm just going to write some zeros here. It doesn't really matter if you get the wrong number of zeros. So we're saying how many times does 12 go into 5? Well, 12 doesn't really go into 5. It goes no times, and there is a remainder of 5. Once again, remember, decimal point above decimal point. So now I say, how many times does 12 go into 50? Well, 12 goes into 50 4 times. 4 times 12 is 48. There are 2 more needed to get to 50. So now I'm saying, how many times does 12 go into 20? Well, 12 goes into 20 once. 1 times 12 is 12. There are 8 left over. You go 1 times 12 is 12. You need 8 more to get to 20. All right, 12 into 80. Well, 12 times 6 is 72 with 8 remainder. 12 into 80. Well, it goes 6 times with 8 remainder. How many times does 12 go into 80? It goes 6 times with 8 remainder. So what you can see here is we've entered into this loop. I'm going to keep getting 6s up here, remainder 8. I'm going to keep doing 12 into 80, over and over and over again. So hopefully now you can see the pattern. This is just going to go on and on like this. The 6s are just going to keep going forever and ever. So 5 over 12 is equal to 0.41. Only the 6s are recurring, so I only put a dot over the 6s. 5 over 12 is equal to 0.416 recurring. Now that we've seen the pattern, we can stop there. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.